And welcome back. In the previous video, we understood some of the container fundamentals, like how containers work in an isolation, and you can have your dependencies installed inside the container without you really worrying about the underlying operating system, because the communication between the container and the underlying operating system happens through something called as a container daemon, right? So in this video, we are going to compare the containers with something called as virtual machine. And this is something on which you've been traditionally, working and see the various pros and cons, the advantages and disadvantages of the virtual machines versus containers, right? Let me again go back to the drawing board and make a nice drawing for you to see if we can understand this better. All right, so in the old in the container world, this is how you would work, right? So you have your you have your container here, and your apps are working inside the container, right? As we learned in the previous video, your dependencies are also there, and somewhere over here you have your container engine, yeah, your container engine, uh, and all this is sitting on on a machine, right? On a hard baked machine, which we call as server, right? We call this a server. All right, now here somewhere below you will have your OS, right? And this OS will have its kernel, right? Let me write it down over here. And as we saw in the previous video, the applications are going to interact with your container engine, and container engine in turn is going to interact with the kernel, right? Now let's shift, the discussion towards virtual machine. Let me just name this as, the what you call the container environment, ENV. All right. Let me, shift the discussion a little bit towards the virtual machine. So what happens in virtual machines is you have your own, your OS, your host OS, right? And this host OS will have a kernel of its own, right? Your Mac OS or a Windows or a Linux. And then over here, you will install something called as a hypervisor, right? You might have heard about this a lot. So Oracle VirtualBox, or your Fusion, or Parallels on Mac OS. They are all the example of hypervisors. Zen in the case of Linux also is a kind of hypervisor. And this hypervisor lets your VMs interact with the kernel. Now, what do you do? What you do is you install your VM, right? You create your VM, you install your VM. Let's say this is one VM, which is where you have your, let's call this as VM1, right? There you will have your apps and your dependencies, and it's basically a your full-fledged operating system. And because of that, it will have an OS, or a kernel and a kernel of its own, right? So let's say this is a Windows machine, right? And then let's say you have gotten the virtual machine here, which is, let me make it and then name it. All right, so let's name it as VM2, right? Let's say it is a Linux machine. All right, and again you'll have your apps and dependencies here, and obviously you'll have a Linux OS and a kernel, your Ubuntu, or whatever is the operating system of your choice, right? Now this kernel is going to interact with your hypervisor when you work on these VMs, And this hypervisor in turn is going to interact with your base or a host kernel. Now, this kind of arrangement has its own advantages. It's completely isolated, from what you call another VM. So, in very dire circumstances, this VM1 is going to interact with your VM2, right? It's highly secure, right? Isolated environment. But the disadvantage of this setup is that it's very, very performance inefficient. This will have, each VM is going to use its own RAM, its own processing core, which can be very, very performance inefficient. What you're doing is, the problem area is this, right? Kernels on top of kernels. And then what happens is, over a period of time, it becomes very, very slow, right? And that is where the concept of container comes to the rescue. Here you have got only one kernel, right? And your container engine is doing the job of interacting with the kernel. Tomorrow if you want, you can have another container over here, right? On the same machine. That container, let's call it as C2. That container, through the container engine, is going to interact with the kernel in turn back here, right? So the container environments, although are not as isolated, right, or running in isolation as your virtual machine does, but they are highly performance efficient, and that's where they are, highly preferable. In the next session, we'll learn a few more things about containers, and then we will move on, right? So see you there.